May 3rd, 1975. Newport News Shipbuilding and Dry Dock Company in Virginia. A crowd of naval officers, government officials, and shipyard workers gathered for a ceremony that would mark a new era in naval warfare. The United States Navy was commissioning USS Nimitz, hull number CVN-68, the lead ship of a new class of nuclear-powered supercarriers. The ceremony was formal and traditional, with speeches about American naval power and the importance of maintaining control of the seas. But beneath this ceremonial language, everyone present understood they were witnessing something extraordinary. Nimitz was not just another aircraft carrier. It was the largest, most powerful, most technologically advanced warship ever built. Nimitz was 1,092 feet long, longer than 3 football fields placed end to end. The flight deck was 4.5 acres of reinforced steel. The ship displaced over 90,000 tons fully loaded, making it one of the largest moving objects ever created by human engineering. The island's superstructure rose more than 20 stories above the waterline, giving radar and communications equipment commanding views in all directions. 4 bronze propellers, each weighing 66,000 pounds and standing 21 feet tall, could drive this enormous vessel through the water at speeds exceeding 30 knots, faster than most merchant ships, despite weighing as much as a skyscraper. But size alone did not make Nimitz revolutionary. The true innovation was the propulsion system. Deep in the hull, protected by layers of armor and compartmentalization, were 2 Westinghouse A4W nuclear reactors. Each reactor used enriched uranium fuel to generate heat that produced steam, which drove turbines connected to the propeller shafts. The 2 reactors together produced 260,000 shaft horsepower, enough power to supply electricity to a city of 100,000 people. More importantly, nuclear propulsion gave Nimitz effectively unlimited range and endurance. The ship could steam at full speed for 20 years without refueling. It could cross oceans, operate in combat zones, maneuver at high speed, all without ever needing to stop for fuel. This capability transformed carrier operations in ways that were difficult for observers to fully appreciate without understanding the logistics of conventional naval power. A conventionally powered carrier burned enormous quantities of fuel oil. At cruising speed, a Forrestal-class carrier consumed approximately 8,000 gallons of fuel per hour. At high speed during combat operations, fuel consumption could exceed 15,000 gallons per hour. A carrier task force with conventional propulsion required constant resupply from tankers, which had to accompany the fleet or rendezvous US at predetermined locations. This dependency on fuel logistics constrained operations, limited flexibility, and created vulnerabilities. If tankers were attacked or delayed, the entire carrier group had to reduce speed or withdraw to refueling points. Nimitz had none of these constraints. The ship could operate at full combat tempo indefinitely, limited only by the endurance of the crew and the capacity of food stores and aviation fuel. And even aviation fuel, which the carrier needed to launch and recover aircraft, could be used more efficiently because the ship itself never consumed it. Every gallon of jet fuel loaded onto Nimitz went to aircraft operations, not to moving the ship. This meant Nimitz could sustain air operations longer than any conventional carrier of similar size. The flight deck was equipped with 4 steam catapults, massive machines that use steam, generated by the nuclear reactors to accelerate aircraft from 0 to 150 miles per hour in less than 300 feet. Each catapult could launch an aircraft every 45 seconds, meaning the carrier could launch 4 aircraft nearly simultaneously and cycle through its entire air wing in less than 30 minutes. This launch rate was critical for generating the kind of sustained air operations that modern naval warfare demanded. Enemy attacks happened fast. Air defense required getting fighters into the air quickly. Strike missions required coordinating large packages of aircraft launched in tight sequence. Nimitz's catapult system made all of this possible. The air wing that Nimitz carried was itself a formidable force. In 1975, a typical carrier air wing consisted of approximately 90 aircraft. The centerpiece was 2 squadrons of F-14 Tomcats, the most advanced carrier-based fighter in the world. The F-14 was a twin-engine, variable sweep-wing interceptor designed specifically to defend carrier battle groups from Soviet long-range bombers and cruise missiles. It carried the AWG-9 radar system, which could track 24 targets simultaneously and engage 6 of them with AIM-54 Phoenix missiles at ranges exceeding 100 miles. The F-14 gave American carriers the ability to establish air superiority over vast areas of ocean, detecting and destroying threats before they could get close enough to attack the carrier. Supporting the F-14s were squadrons of A-6 Intruders and A-7 Corsairs, attack aircraft designed for strike missions against enemy ships and land targets. The A-6 was particularly capable with all-weather radar that allowed it to find and attack targets in conditions that would ground other aircraft. It could carry 18,000 pounds of bombs or missiles, more than many World War II heavy bombers, and deliver them with precision from low altitude. The combination of F-14 fighters providing air superiority and A-6 attack aircraft delivering strikes gave a carrier battle group the ability to project power hundreds of miles from the ship. Additional aircraft included E-2 Hawkeye airborne early warning planes, which used powerful radar to detect incoming threats and coordinate defensive responses. EA-6B Prowler electronic warfare aircraft that could jam enemy radar and communications. S-3 Viking anti-submarine planes that hunted for enemy submarines, and helicopters for search and rescue, anti-submarine warfare, and logistics. The entire air wing operated as an integrated system, with each aircraft type contributing to the overall mission of the carrier battle group. Soviet naval intelligence tracked the construction and commissioning of Nimitz with great interest and growing concern. The Soviet Navy had been expanding rapidly through the 1960s and 1970s under Admiral Sergei Gorshkov, who had transformed what was essentially a coastal defense force into a blue-water navy capable of global operations. The Soviets had built cruisers, destroyers, submarines, and support ships in large numbers. They had developed long-range naval aviation, including bombers armed with anti-ship missiles, designed specifically to attack American carriers. But the Soviet Navy had no true aircraft carriers. Soviet naval doctrine held that carriers were vulnerable, expensive, and unnecessary for Soviet strategic needs. The Soviet Union did not project power globally through carrier-based aviation the way the United States did. Soviet strategy emphasized land-based aviation for air cover, submarines for attacking enemy shipping, and the surface ships armed with missiles for fleet defense and power projection. Carriers were seen as targets, not assets, ships that absorbed resources without providing capabilities that could not be obtained more efficiently through other means. This doctrine was partly strategic calculation and partly necessity. The Soviet Union lacked the industrial capacity and technical expertise to build large carriers. Soviet shipyards were smaller than American facilities and lacked experience building ships the size of Nimitz. Soviet nuclear propulsion technology, while adequate for submarines, had not been scaled up to carrier-sized reactors. Soviet naval aviation had no aircraft comparable to the F-14 or A-6, nothing that could operate from a carrier deck with the performance and payload of American carrier aircraft. Building carriers would require the Soviet Union to develop entire new categories of technology and industrial capability, an investment that would take decades and might never achieve parity with American capabilities. Instead, the Soviets built what they called tactical aviation cruisers, ships designated as cruisers rather than carriers to comply with international treaties governing transit through the Turkish Straits. The Kiev class, the first of which was commissioned in 1975, the same year as Nimitz, represented the Soviet approach to carrier aviation. Kiev was a hybrid ship, part cruiser and part carrier. The forward section was equipped with anti-ship missiles, surface-to-air missiles, anti-submarine rockets, guns, and sensors, making it look like a heavily armed cruiser. The aft section had a short flight deck capable of operating helicopters and vertical takeoff aircraft. The aircraft Kiev carried were Yak-38 Forgers, Soviet VTOL fighters inspired by the British Harrier. The Yak-38 could take off and land vertically, eliminating the need for catapults and arresting gear. This seemed like an elegant solution, allowing the Soviets to operate fixed-wing aircraft from relatively small ships without the enormous complexity of conventional carrier operations. But the Yak-38 had crippling limitations. To achieve vertical flight, the aircraft used three engines: one main engine for forward flight and two lift engines that operated only during takeoff and landing. These lift engines consumed enormous amounts of fuel, severely limiting the aircraft's range and loiter time. In hot weather, the engines lost thrust and the aircraft sometimes could not take off at all with any meaningful weapons load. The Yak-38's combat performance was poor compared to American carrier aircraft. Maximum speed was approximately 650 miles per hour, slower than the F-14's top speed of over 1,500 miles per hour. Combat radius was about 200 miles, less than half the F-14's range. Weapons payload was limited to about 4,000 pounds compared to the F-14's capacity of over 14,000 pounds. The radar and avionics were primitive, giving the pilot limited ability to detect and engage targets beyond visual range. And the aircraft was notoriously unreliable, with engine failures and systems problems that made it dangerous to operate. Kiev could carry about 30 aircraft total, including a mix of Yak-38 fighters and helicopters. This was less than one-third the air wing of an American supercarrier. And the capabilities of those 30 aircraft were far inferior to what American carriers could deploy. A Kiev-class ship could provide limited air defense for itself and nearby vessels, could conduct some reconnaissance, could attack targets within short range, but it could not establish air superiority over a large area, could not conduct sustained strike operations against defended targets, could not project power the way an American carrier could. When Soviet naval officers compared Kiev to Nimitz, the disparity was staggering and deeply troubling. Nimitz displaced 90,000 tons to Kiev's 40,000 tons. Nimitz was 1,000 feet long to Kiev's 900 feet, but the real difference was in the configuration. Nimitz had an unobstructed flight deck running the entire length of the ship, allowing simultaneous launch and recovery operations with large aircraft. Kiev had a short deck cluttered with weapons and sensors capable of operating only VTOL aircraft and helicopters. Nimitz carried 90 high-performance aircraft. Kiev carried 30 limited-capability aircraft. Nimitz could launch 4 aircraft simultaneously every minute. Kiev's VTOL aircraft required several minutes between launches. Nimitz could sustain air operations indefinitely with nuclear propulsion. Kiev needed refueling every few days. Most critically, the quality of aircraft made the comparison almost laughable. An F-14 Tomcat could detect and destroy a Yak-38 from beyond visual range before the Soviet pilot even knew an American fighter was nearby. The AWG-9 radar in the F-14 would track the Yak-38 at distances exceeding 50 miles. The F-14 pilot would maneuver into an optimal firing position, launch an AIM-54 Phoenix missile, and the Yak-38 would be destroyed before its pilot's radar warning receiver even detected the threat. If somehow the engagement came down to a close-range dogfight, the F-14's superior speed, climb rate, and maneuverability would make the outcome inevitable. The Yak-38 had no chance in air-to-air combat against modern American fighters. Soviet admirals who understood these disparities realized that the Kiev-class ships, despite Soviet propaganda calling them aircraft carriers, were not carriers in any meaningful sense. They were helicopter cruisers with limited fixed-wing capability, useful for anti-submarine warfare, and fleet air defense against moderate threats, but utterly incapable of competing with American supercarriers. A single Nimitz-class carrier could dominate an entire ocean region, establishing air superiority, conducting strikes against land and sea targets, defending against air and submarine threats. Kiev could barely protect itself. The implications for naval strategy were profound and depressing from a Soviet perspective. The United States Navy operated multiple carrier battle groups, each centered on a nuclear-powered supercarrier with an air wing of 90 aircraft. By the early 1980s, the U.S. would have 4 Nimitz-class carriers plus several older, but still capable carriers from the Forrestal and Kitty Hawk classes. These carrier groups could operate anywhere in the world, projecting American power, threatening Soviet interests, supporting American allies intervening in regional conflicts. Soviet naval forces could challenge American carriers in specific circumstances using submarines and land-based bombers armed with anti-ship missiles. But the Soviets could not match American carrier capabilities and could not project equivalent power globally. Soviet naval officers who observed Nimitz during port visits or tracked the carrier during operations came away with deep respect for American engineering and strategic vision. The ship represented capabilities that the Soviet Union simply could not duplicate. The nuclear propulsion alone was beyond Soviet industrial capacity at the scale Nimitz required. Soviet reactors were less powerful, less efficient, more prone to problems. Scaling them up to carrier size would require development programs lasting years, perhaps decades. The catapult systems, which use steam from the reactors to accelerate heavy aircraft to flying speed in seconds, required precision engineering and materials that Soviet industry struggled to produce. The arresting gear, which caught aircraft landing on the deck and brought them from landing speed to full stop in a few hundred feet, required similar precision and quality control. The aircraft themselves highlighted the gap even more starkly. The F-14 Tomcat was a masterpiece of aviation engineering, incorporating variable sweep wings that optimized aerodynamics for different flight regimes, powerful engines that gave the aircraft performance across a wide envelope, sophisticated radar and weapon systems that made it the most capable fighter in the world. Soviet engineers who studied intelligence reports about the F-14 understood that they were years away from developing anything comparable. The radar alone, the AWG-9 system capable of tracking 24 targets and engaging multiple threats simultaneously, represented electronic sophistication that Soviet industry could not match. The A-6 Intruder was equally impressive in its own way. This subsonic attack aircraft did not have the glamour of the F-14, but its all-weather radar and heavy payload made it enormously effective for strike missions. Soviet naval aviation had nothing comparable. Soviet naval strike aircraft were either land-based bombers that could not operate from carriers, or limited capability aircraft like the Yak-38 that could barely defend themselves, much less conduct effective strikes against defended targets. The gap in attack aviation was as large as the gap in fighters. Soviet admirals who reported back to Moscow after observing American carrier operations described capabilities that seemed almost impossible given Soviet understanding of naval warfare. They reported that American carriers could maintain continuous air operations around the clock, with aircraft launching and recovering at rates that kept dozens of planes in the air simultaneously. They reported that American carrier air wings could conduct strikes against targets hundreds of miles away, delivering thousands of pounds of ordnance with precision and return safely to the carrier. They reported that American carriers could defend themselves against air, surface, and subsurface threats using combinations of fighters, electronic warfare aircraft, early warning planes, and sophisticated sensors that created defensive bubbles extending hundreds of miles from the ship. The word that kept appearing in Soviet assessments was impossible. Not impossible in the sense of violating physical laws, cray, but impossible in the sense that Soviet industrial and technological capabilities could not reproduce what the Americans had achieved. Building a ship the size of Nimitz was possible. Soviet shipyards had built large ships before. Building nuclear reactors was possible. Soviet submarines had nuclear propulsion. Building catapults was possible. The physics and engineering were understood. But building all of these systems together, integrating them into a functional carrier, developing aircraft that could exploit the carrier's capabilities, training crews to operate at American performance levels, sustaining operations at American tempo, all of this seemed beyond Soviet capacity. One particular aspect that Soviet observers found remarkable was the quality of construction and maintenance. American carriers were built to extraordinarily high standards, with attention to detail in every system. Welds were inspected and tested, Components were manufactured to tight tolerances. Systems were redundant, with backups for critical functions. Quality control throughout construction ensured that what was designed on paper actually functioned as intended when built. This level of quality was expensive and time-consuming, but resulted in ships that were reliable and effective. Soviet shipbuilding, by contrast, suffered from chronic quality problems. Ships were built quickly to meet production quotas, often with inadequate attention to detail. Components were manufactured to looser tolerances with less consistent quality. Systems failed more frequently and required more maintenance. Ships spent more time in port for repairs and less time at sea operating. Soviet naval officers who visited American carriers and saw the condition of the ships, the cleanliness, the organization, the obvious care in maintenance, understood that Soviet shipyards and crews did not maintain equivalent standards. The crew quality was another difference that Soviet observers noted. American carrier crews were well-trained professionals who took pride in their work. Sailors operated complex systems competently, maintained equipment properly, followed procedures carefully. Officers understood their ships and aircraft thoroughly and made sound tactical decisions. The entire crew functioned as a cohesive team that had trained together extensively. Soviet crews, while often brave and dedicated, received less training, had less experience with their equipment, and operated within a more rigid command structure that discouraged initiative. Perhaps most telling was the difference in operational philosophy. American carriers were designed to project power offensively, to sail anywhere in the world and conduct operations as needed to support American interests. Soviet naval doctrine was fundamentally defensive, focused on protecting Soviet territory and threatening American carriers before they could get close enough to launch strikes against Soviet targets. This defensive mindset reflected the Soviet Union's position as a land power that used its navy primarily to support ground forces and defend the coastline, not to project power globally the way a maritime power like the United States did. The economic implications were also sobering for Soviet planners. Nimitz had cost approximately $2 billion to build in 1975 dollars. The Nimitz-class program would eventually include 10 carriers, representing an investment of tens of billions of dollars in ships alone, not counting the aircraft, weapons, training, support infrastructure, and personnel costs. The United States could afford this investment because its economy was large, diverse, and productive. The Soviet economy, despite impressive growth in some sectors, could not match American economic output. Allocating resources to build American-style supercarriers would require sacrificing other military programs or civilian needs, trade-offs that Soviet planners were reluctant to make. Soviet attempts to develop their own large carriers in the 1980s illustrated these challenges. The Admiral Kuznetsov, laid down in 1982 and commissioned in 1990, represented the Soviet Union's most serious effort to build a true fleet carrier. At 67,000 tons, Kuznetsov was significantly smaller than Nimitz, but much larger than the Kiev-class ships. The design incorporated a ski-jump bow that allowed aircraft to take off using their own power without catapults, a simpler solution than steam catapults but one that limited aircraft weight and payload. The air wing consisted of about 40 aircraft, including Su-33 fighters, significantly more capable than the Yak-38 but still inferior to American F-14s, or FA-18s. Kuznetsov was conventionally powered using steam turbines and fuel oil, which meant it required frequent refueling and could not sustain operations at the pace of nuclear-powered American carriers. The ship suffered from quality problems throughout construction and experienced numerous mechanical failures during sea trials. Smoke from the engines was visible for miles, negating any attempt at tactical surprise. Reliability was poor, and the ship spent large portions of its service life in port for repairs. When Kuznetsov did operate, it demonstrated that Soviet industry could build a respectable carrier, but one that lagged American capabilities by at least 15 years and cost enormous resources that the declining Soviet economy could barely afford. The other Soviet carrier project, the Ulyanovsk class, would have been nuclear-powered and equipped with steam catapults, making it more comparable to American carriers. but construction halted when the Soviet Union collapsed in 1991 and the incomplete hull was scrapped. The Soviet Union never succeeded in fielding a carrier force comparable to American capabilities. The technological, industrial, and economic gaps were too large to overcome before the Cold War ended. American naval officers were aware of Soviet assessments and took satisfaction in knowing that Nimitz and her sister ships gave the United States a decisive advantage in naval power projection. But they also understood that carriers were not invulnerable. Soviet submarines posed a serious threat. Soviet bombers armed with long-range anti-ship missiles could attack carriers from standoff distances. Soviet surface ships with powerful missiles could threaten carrier groups in certain scenarios. American carrier doctrine evolved to address these threats through layered defense: submarines screening ahead of the carrier group, destroyers and cruisers providing area air defense, fighters maintaining combat air patrol, early warning aircraft detecting threats at long range, electronic warfare aircraft jamming enemy sensors and communications. The carrier battle group concept integrated all of these defensive and offensive capabilities into a mobile, flexible force that could adapt to different threats and missions. The carrier was the centerpiece, providing the air power that made everything else possible. But the effectiveness of the battle group depended on every ship, every aircraft, every sensor, every weapon working together. This integration required sophisticated command and control systems, extensive training, operational experience that came from decades of carrier operations. The Soviet Navy, even if it had built carriers comparable to Nimitz, would have taken years to develop equivalent operational proficiency. When the Cold War ended in 1991, the United States Navy operated 15 carrier battle groups, including 6 Nimitz-class carriers with 4 more under construction. The Soviet Navy operated one troubled carrier, Kuznetsov, which would soon be inherited by Russia and would spend much of the next 3 decades in repair yards. The disparity in carrier power was one of many asymmetries that characterized the final years of the Cold War, evidence that American industrial capacity and technological sophistication had decisively outpaced Soviet capabilities despite enormous Soviet investments in military modernization. Soviet admirals who had called Nimitz impossible when they first observed the ship in 1976 were proven correct in a sense. For the Soviet Union, with its industrial limitations, technological gaps, economic constraints, and strategic culture, building and operating supercarriers like Nimitz was effectively impossible. Not impossible in absolute terms, but impossible given the realities of Soviet capabilities and priorities. The Soviet Union could build impressive weapons in many categories. It developed excellent submarines, capable fighters for land-based operations, powerful missiles, sophisticated air defense systems. But aircraft carriers, especially nuclear-powered supercarriers like Nimitz, required a combination of technologies and industrial capabilities that the Soviet system could not generate. Nimitz herself continued operating for nearly 50 years after commissioning, a testament to the robust design and quality construction. The ship deployed repeatedly to every ocean, participated in numerous conflicts and contingency operations, and demonstrated the enduring value of carrier-based power projection. The Nimitz-class carriers became the backbone of American naval power through the end of the 20th century and into the 21st, providing capabilities that no other nation could match. Even today, decades after the end of the Cold War, only the United States operates nuclear-powered supercarriers comparable to Nimitz. Other nations have built carriers, some quite capable, but none match the size, power, aircraft capacity, and operational tempo of American supercarriers. The day Soviet admirals first saw USS Nimitz and understood what American industry had created was the day they realized that naval parity was impossible, that the gap between American and Soviet carrier aviation was not years but decades, and that closing that gap would require investments and capabilities that the Soviet Union did not possess. The recognition was professionally humbling and strategically sobering. American carriers represented power that the Soviet Navy could not match, force projection capabilities that Soviet doctrine could not counter, technological sophistication that Soviet industry could not duplicate. Nimitz was not just a ship, it was a symbol of American technological and industrial dominance, floating proof that the competition between Soviet and American military power was asymmetric in ways that favored the United States decisively. Soviet admirals looked at Nimitz and saw the future of naval warfare, a future in which Soviet naval power would always be playing catch-up to American capabilities, never quite closing the gap, always striving to counter advantages they could not replicate. That realization, more than any single battle or confrontation, defined the naval dimension of the Cold War and foreshadowed the eventual outcome of that long competition.